All right, welcome back to another episode of the book learning series. I'd like to keep working on wild networking eventually, but that's gotten like pretty tedious and dry with just reading the RFC. And this book so far has been really, really excellent. I kind of knew this book would be really good, but I never quite got around to reading it. So that's what I'm going to be focusing on, I think, from now. Until as far as I know, I just want to read this whole book as soon as I possibly can. Looks like I'm already 12% done with it, so it should only be like a few weeks until I've read the whole book. So that's my goal for now, is just to read this whole book. So the next section of chapter 2 is using regular expressions to search text. The Apache HTTP server is an open source web server widely used to serve web content. And before I go any further, I'm going to bring up my GNS lab here because I have a Apache server I can play with on there. So, oops, it looks like it's reaching out to the... Oh, did I accidentally do something? Maybe I unplugged it somehow by accident. I might need to go check on my server. It looks like I might have, I could see that happening. I accidentally unplugged the Ethernet cable on it or something. Oh no, okay. It just took a while to load for some reason. Okay, so if I go down here and I click New Template, and then Install from an appliance, and then go to Guests, I should have an Apache server. Or like a web server. Yeah, here's like a web term, I guess. I'm not sure what that is. Let's try this. But anyways, Apache is just a open source program, so I can just install Apache onto a server. I don't have to there's no such thing as an Apache server. There's a server that has Apache. Okay, but we'll take a look at what this is. This looks like it might be a image setup for web applications. But while that's going, let's boot this up and take a look at if Apache's on there. Because I want to follow along with the examples from now on. So I think I can do that with the lab. So I'm going to boot this up, and then boot this up, and then get right back to reading it. And hopefully, if there's examples, we'll be able to follow along using these. The web server can be configured to save log files in different formats. One widely used format is the common log format, CLF. A variety of log analysis tools can understand this format. Below is the layout of this format. What follows is an example line from a log in this format. Chapter 1 introduced you to regular expressions and the Python RE module. So let's use it to pull information from a log in the common format. So this is the common format for Apache logs. One trick to constructing regular expressions is to do it in sections. Doing so enables you to get each sub-expression working without the complication of debugging the whole expression. You can create a regular expression named groups to pull out the IP address from a line. Okay, so let's follow along on this. And I won't need to use my lab for this. I've got a local folder I've been using. Once we start getting into more advanced stuff, like reaching out to network gear and using Apache and stuff like that, then I can go and use my lab. Okay, so let's activate the virtual environment. Right. And we'll start an Ipython terminal. All right. Oh, okay. It's getting a little bit complicated here. Shoot. Actually, I might want to switch over to Apache right now, or maybe this web term. Okay, so this is what I get when I open that web term. I don't know. This looks like a... I'm not sure what this is. I don't think this is what I'm looking for. I think I can delete this. Okay, but let's install Apache on this, and then try to get some logs. Whoops. So I'm having trouble opening a console to it. Still having trouble. Okay, there we go. Okay, so let's see if... Okay, let's see how to get Apache. Yeah, so this is an Ubuntu server. So we're going to install and configure Apache. Okay. Oh, it says that we need 16.04. I don't have that. I'm not sure what I have. Yeah, I'm not sure what I have. 16.04. I thought this was how you checked. Oh, do I even have Ubuntu? Yeah, I have Ubuntu. Let's take a look here. So, how to check the version of Ubuntu. I thought it was... Oh, here we go. Okay, this is... Oh, okay. So yeah, that's what I thought. I'm at 1804. So I don't know if I can do it. I'll try it. Oh, I don't have sudo on here. I've got root privileges automatically. Oh, I still don't need to do... Oh, and I accidentally hit exit, so let's get back in there. Hopefully it doesn't take as long to boot up this time. Oh, it looks like when I hit exit, I might have accidentally stopped it. I don't know why this is giving me so much trouble. I just haven't used this in a while, so it's not under my fingers. Pushed return. Yeah, this is being not fun to work with, but we will get... Why don't I do this? I'm just going to copy this. Then I don't need to worry about having that sudo in there. That's why it was difficult last time. Ah, here we go. So now we're... oh, it looks like we were collecting... Okay, perfect. Here we go. Excellent. Now we're getting started. So now what I can do is log into this device using a browser. So but so if I do IPA, ifconfig rather, now I can go here in my browser. HTTPS maybe it's the other interface. Might be the other interface. Oh, there's only one interface. I thought there were two. Oh, maybe I didn't. Okay, well that didn't work. Let me try going to etc Apache 2. There we go. Yeah, and now let's do config or cd. I wish I could. Oh, you know what? It's probably that apache2.conf is what I'm looking for. Yeah. Yeah. So, can I change the IP? Oh. Maybe it's ports.conf is what I'm looking for. I don't know what I'm looking for. I'm looking to make it so that I can put the IP there of the interface connecting to the cloud and get to the Apache welcome page. That's what I'm looking for. Yeah, so it's virtual. Did I need to? Uh-oh. Oh, I have to give it a... Okay, I have to give it a directory name. Or... Huh. Yeah, I don't know how to... I mean, my goal was to follow these instructions, and I did that. But, well, again, I'm not running 16.0, so let's see if I've got some log files, though, because that's really all I wanted to do. So we're going to grep. Oh, you know what? But we're not doing any HTTP calls or anything like that. But let's look for this HTTP slash and see if we've gotten any files with that in it. Okay, so looks like we're not. Okay, so we do get some positives here, but that's not the logging file. You know what? Maybe I can just do this. I can find an example Apache log file. Yeah. Okay, here we go. Perfect. So this is what we're going to use as our Apache file to follow along with the example here. So learned about the exclamation point. I can do whatever commands my operating system allow for. My operating system is Windows. I'm in a PowerShell terminal, so I can use the Notepad command and create a file named Apache log.log. Okay, and now, yes, we're going to create a new file. We're going to paste that in there, save it, and close it. Okay, and now we can follow along with this. So we learned in the previous chapter how to pull in the log. I already knew that, but it would be with, open Apache log.log for reading as F. They say open file, but F is what is usually used. We're going to do read lines so that we get back a dictionary. So now if we do and we're going to save it to let's do this. So let's do line equals read lines, but then we only want the first one. So if I print out line, I've got a syntax very similar to what they have there. So if I do a search and try to find an IP address, we should get that first one listed there, the 111.222 address. So we gotta, of course, import the RE first, and then re.search. All right, and we found a match. We've got a match object, and in fact, the match object tells us the match. Exactly what I expected to see right up here. We found the IP address. Okay, so now we can go back to that re.search, and we can save that match object into a variable. Okay, so type M is a match object. If I look at the match object, there it is, same one that was up there before. So now that we have this match object, we can just look at the group because we named a group here. We did a yeah, I mean, this is why, like, this is a pretty complicated regex right here, right off the bat, but they're expecting you to know regexes really well. But here we can see, oh, I see, because it's in a group with these parentheses here, we can specify the group and just get that. We can also specify by name because we've got this syntax here with the name of the group here. So So yeah, that's pretty awesome. Yeah, I don't know. I should use more regular expressions. But anyways, you can also create a regular expression to get the time. All right, so let's do that. Oops, so it looks like we didn't get a match. We didn't get a time. I might not have entered the regex in properly. I mean, I wish. Oh, okay. It looks like the video never stopped running, so you might have heard me say, "God damn it!" But I won't have to upload 2 videos. Last time I made a video, I had a problem, so I just uploaded part 1 and part 2. But it looks like I can keep going here. The problem I'm having is I'm not getting a match, so I wish I could just, copy this, but they're not allowing for that, probably because they don't want you to be able to steal the book, however they consider that to be the case. So I will have to type everything out. So let's see here. So, okay. All right, and then we've got a cap. Yeah, I'm just going through this character by character, being sure that I did everything right. Oh, it looks like I already got a mistake here. I put a W in there instead of a 3. All right, let's see if we get a match object now. Oops. Okay, we still don't have a match object. You have to run this one first because M was defined with the old definition of R. So I had to run this line again, but even after I ran it, I still didn't get a match type. So I think there's another error here. Let's try to find it. W3. Oops, so yeah, I can see I've got my backslashes flipped. There you go, it should look like a tent. There you go, \D. There we go. Okay, that looks a lot better. So now we're going to need to define a new match object, hopefully, if there is a match. Well, even if there isn't a match, you'll still have a match object, but the match object will be a none type. But, oh, yeah, so right now, oh, actually, never mind. If there isn't a match, you won't get a match object, you'll just get a none type object. So you can see right now I've got an untype object. There's no match, which is strange. Like, there should be a match. So let's look over the regex. So yeah, we've got time, then we've got \d, \d, then we've got a tent, and then we've got a w3, another tent, d4, :/42, colon \d2, colon \d2, colon \d2, in parentheses. Okay, so this is definitely the correct regular expression. It's just, it might not be suitable for my file. So let's see here. So they've got, okay, so the first thing we're looking for is 2 digits. So here's a match here. We've got 2 digits. The next thing we're looking for is a /. We've got a / here. After that, we're looking for a word with 3 characters within it. We've got that here. Then we're looking for another /. We've got that here. After that, we're looking for a digit with 4 characters. We've got that here. Then we are going to be looking for a colon. Got that here. Then we're going to be looking for 2 digits. Got it. Colon. Got it. 2 digits. Got it. Colon. Got it. 2 digits. Got it. So we should have a match here, but for some reason we don't. Why the heck not? What the hell? That makes no sense. God damn it. And you can see just how hard it is to read regexes a lot of the time. Like, why is it not? Oh, the other thing is it's looking for a open bracket, which we can see here. Aha! And now I found out why it didn't match. Because it's looking for a closed bracket right after here. But that's not what our timestamp has. Our timestamp has a closed bracket after this like microsecond count. So it looks like ours has an extra section that theirs do not. So yeah, you can see their timestamp here doesn't have that extra dash and then those extra digits. So it doesn't record the microseconds. It looks like it just records the hours, minutes, and seconds, but no milliseconds. So mine has milliseconds, so it's not going to have a match there. What we can do is redefine our match terms, and we can just take out this last bracket. And then we can see, and I'd like to take out the first bracket as well, just because I don't think that's relevant. Oh, you know what? Let's leave that in there because that's not part of our matching group. So if we want, so that will I'll leave in there to further explain what a matching group is. So now that we've got our matching criteria, let's see if we can get a match object. Okay, so let's see what type M is. If it's a none type, we didn't get a match. Aha, so we see we've got a re.match object instead of a none type object, so we did find a match this time. Let's see what we got. So m.group. Okay, so we found a timestamp there. You can grab multiple elements, as has been done here. The IP, user, time, and request. So, all right, so it looks like they're going to do a new match criteria here. So R equals raw string is what that stands for. I'm not sure why they're using R. I guess regex. Yeah, R for regex. Okay, and then here's so this parentheses is opening a new match group. A match group is something you can narrow down on your string by having a match group here. So, and then you can name your match groups as well by using question mark P, and then in these two greater than and less than signs, you can put what you want that name to be. So we're going to choose IP, and then we're going to be looking for an IP address. So an IP address has a digit, and it doesn't have a digit one or more times. It has a digit. Sometimes 1 digit, sometimes 3 digits, but it won't ever have 4 digits. So this really isn't the best regex to use to find an IP. I think you can do something like this, and then that way you're only searching for, actually I think it would be like that. So now you're only searching for a digit 1, 2, or 3 times. If there's a 4th digit, it doesn't count. So that I think would be a better regex to use. So let's try using that one instead. Okay, and then we'll do the same thing. There we go. Okay, so that's my regex, and I'm sticking to it. It's a little bit different than the one they have, but it's different because it's actually better. There they could have a false positive if you had a octet in your IP address that was invalid. And even mine is still not quite good enough, because if let's say one octet was 999, that wouldn't be a valid IP address, but my regex would still match it. Okay, but let's do this next line here. R plus equals, so we're building out, we're adding to what we had before. Go, and then R plus equals. All right. Oh, something happened. Oh, I used the wrong. Okay, so I've got to use a single quote to define this string because the string has double quotes in it. All right, moving on to the next page. Oh, so we didn't get a match this time. I don't know if I typed it in wrong or what happened. Oh, you know what? What happened is here I used the bracket again. So why don't I make this easy on myself? I'm going to do Notepad, and then yeah, Apache log, and then we'll just add a bracket there so we get a match. There we go. So that's not what a log is actually going to look like, but that'll allow us to do this a bit more seamlessly. Oh! Okay, I'm not sure what happened there. Oh, I think we don't have a get request as a part. I thought we would. I was hoping we would, but I don't think we do. Let's take a look. So we do have a get request. But we don't have one that just has the HTTP here. So let's get rid of this and see if we can get that going. Okay, we still don't have it. Oh, you know what? It's because the reason is because I didn't redefine line. So I've got to do my with statement again, all the way at the beginning. Yeah, like all the way here. So yeah, so I need to call this in again. Perfect. Okay. Oh. Okay, now it's really interesting. Why is it not doing what I thought it would do? You know what? I think R. Yeah, R is just okay. It's because there's no match in my file. I could probably still clean it up a bit. Let me try one more thing quick. So yeah, there's not even a username or anything like that in this. So the problem is just my payload I'm working with here isn't the payload they're working with here. So I'm not going to match where theirs would have matched. So I understand what they're doing. I really like this naming here, and I really like how you can split it out like that. But the fact that I can't get the same results they're getting is just simply because they're using a different payload to search through. So on my own time, I would want to use whatever payloads I have. Yeah, but I understand the fact that you can name a match group, and I think that's awesome. I haven't really done anything with that, so that's something I might want to explore more. Parsing a single line of a log is interesting, but not terribly useful. However, you can use this regular expression as a basis for designing one to pull information from the whole log. Let's say that you want to pull all of the IP addresses for GET requests that happened on November 8, 2019. Using the preceding expression, you make modifications based on the specifics of your request. Okay, so you know what? I might not even want to type this all out because it's not relevant to the payload I have. So I'm going to gloss over this and come back to it. So let's keep going. Use the findIter method to process the log, printing the IP addresses of the matching lines. So here you can print them one by one. Oh, sorry. So what you can do with this is you can see we've got matched here, and we've got re.findIter. So now it finds all the entries in the log as a data type called an iterator. And an iterator allows for iteration, which you can do here with a for loop. So you can't print this out, you can't append to it, you can't do things you would do to a string, things you do to a list, things you would do to a dictionary. But what you can do is loop through it. So sometimes that's all you want to do, and you've got to be concerned about, how your code works, how it taxes your system. So an iterator is all you need, so it's all you would want. I generally don't really think about that much. I would probably use re.findAll instead of findIter, because it just gives you back a list with all the IPs in it, but I understand why an iter is probably the better way to do it. I typically don't think about the limitations of the system I'm coding on when I code. Okay, so you know what? Let's try this. Let's do this. Let's make a find iter to get the IP addresses in the payload. So let's take a look at the payload, and then we'll make our own custom search string. Okay, and we'll get the let's get the dates and iterate through. So yeah, so we're gonna do R. Oops, we gotta close this. So R equals, and it's gonna be a raw string, and then we're going to have a match group. The whole thing is just going to be a match group. We're only going to have one match group. Then the other thing we're going to have is we're going to have a name for what we're searching for. I wanted to search for the date. Let's just search for the IP. That's going to be a bit easier. Okay, so now that we have all of that unrelated syntax out of the way to actually matching the terms, let's think about what we want to match. So it's going to be an IP address. So this is going to do it. You'll get some false positives there, but but it will get you all of the true positives as well. So you'll get all your true positives, but you'll get some false positives as well. That's better than getting some of what you want, but not all. So this is going to be just fine. Looks good to me, right? Oh, no, it doesn't. This needs to be there. Okay, there we go. Okay, so here it is. So let's make a let's run this next line and see what we get. Matched equals re.findIter.r, and then let's do. Oh, I wonder if I can do this. That would be awesome. I doubt I can. No way, I can't do that. That would be so cool if I could do that. But let's do it this way. So we're gonna say log equals there. Okay. Log equals echo. Maybe can I do echo? I can't do cat. Oh, what if I do cat? I can't do cat. Yeah. Okay. Well, you know what? I can just do the with. Yeah, and now I can say log equals f dot read and get the whole thing in. There we go. So now I can do this again, but we're going to be searching through log. Okay, and now let's see what we got. So we've got a callable iterator. Let's take a look at what that means. We'll do a help on it. So we can, so we've got iteration. So that means we can do a for loop on it. We've got, and then we've got this next. We can do a match.next and go through. But let's do the for loop like is shown in the book. There you go. There's a lot that you can do with regular expressions and texts of all sorts. If they do not daunt you, you will find them one of the most powerful tools in dealing with texts. Yeah, that's where I'm at now. They daunt me. So I typically use splits and indexing instead of regular expressions, which works. But I do agree that sometimes that's just not quite powerful enough. And if I didn't let regexes daunt me as much, I might be able to get more out of my code. So I'm going to try to work with regexes more than I do. I really think I'm just trying to avoid them, not for good reasons. Basically, I try to avoid regexes because I think they make the code a little bit uglier. But I think there's a trade-off. Like, first of all, I don't necessarily believe that, like, especially because a lot of people know regexes. That's kind of a fundamental of computer science, or computers is learning regexes because they're used a lot. So yeah, that's a big takeaway from this book. I might even highlight that and save that. Yeah, I'm going to save that as a takeaway for this book, is to just use regexes more. It looks like I can't. All right. Well, you know what? I can just remember that. I don't need to note that. Okay, dealing with large files. There are times that you need to process very large files. If the files contain data that can be processed one line at a time, the task is easy with Python. Rather than loading the whole file into memory as you have done up until now, you can read one line at a time, process the line, and then move to the next. The lines are removed from memory automatically by Python's garbage collector, freeing up memory. Note, Python automatically allocates and frees memory. Garbage collection is one means of doing this. The Python garbage collector can be controlled using the GC package, though this is rarely needed. The fact that operating systems use alternate line endings can be a hassle when reading a file created on a different OS. Windows created files have \r characters in addition to \n. These show up as part of the text on a Linux-based system. If you have a large file and you want to correct the line endings to fit your current OS, you can open the file, read one line at a time, and save it to a new file. Python handles the line ending translation for you. Okay. So, oh, that's interesting. Okay. So if you have a large file and you want to correct the line endings to fit your current OS, you can open the file, read one line at a time, and save it to a new file. And then Python will automatically make it work for your operating system. So yeah, we see this with statement here, and then we have another with statement here. The first with statement, we've got a write. That's because this is where you want your data from. The second with statement, we've got a W. The R stands for read. We're going to be reading from this first one because this is your data that has the incorrect line endings. And then the second one here, we can see big data corrected, is for writing, because we're going to write the correction to those line endings. So for line in source file, we're going to write to the target file. And then simply by doing that, those line endings will be corrected. That's cool. I didn't know you could just do it like that. Notice that you can nest. Yeah, I never would have thought to nest with statements. Notice that you can nest the with statements to open two files at once and loop through the source file object one line at a time. You can define a generator function to handle this, especially if you need to parse multiple files a single line at a time. Okay, so let's define that generator function. We won't need to do the first example. I'm skipping that. Just trying to do all the examples within reason. If I feel there's a need to skip it, I'll skip it, but I definitely don't want to do it the way I was doing it before, where I just skip them all. Okay, so this is a generator, so we're going to have a yield statement at the end. Okay, so bigdata.txt. I think I've got a big data file saved up already. Let's do a question mark dir. So I think this is my big data file. Let's take a look at what's in here. We'll do a question mark notepad on that. So it looks pretty big to me. Actually, it looks kind of small. Like, big data is big data. This is not big data. This is small. So it looks like the dir. Okay, so that, I mean, that's, I'm not sure what this is in, but this is definitely the biggest file in there. So this is the file I'm going to be using for my big data. Oh, and it's not called bigdata.txt. It's called what it's called. There we go. Okay, so let's see what we got for reader. What kind of type? We've got a generator now, and that's because generator is just a function with a yield statement. So it's a bit different from a function because it has that yield statement. It saves the state it was run, and then when you run it again, it runs based on that prior state. So here, the prior state, when you run it, is going to be the line in source file. So every time you run it, you're going to yield the line in source file, and you can keep running this until you finish that for loop, and then when you can't run the generator again. Now let's see what line reader is. I don't think I think line reader is actually going to be a function. So I think, yeah, line reader is a function. So sorry, I actually misspoke, and I'm going to clear this up. I'll be back. Okay, so now that the light is on, I'm going to clear up the idea of a generator. I initially said that a generator was just a function with a yield statement, but that's not true at all. A generator is so a function with a yield statement is still a function, but when you run that function, you can save it. What the yield will give you back is a generator. So you can save the output of that function to a variable, and now that variable is a generator. So that's what a generator is. It's not a function with a yield statement. It's what the yield statement gives you. It gives you a generator. So if you save that into a variable, like we're doing here, now we have a generator. But if we do a type on the original function, even though there's a yield statement in there, it's not a generator, it's still a function. So I was wrong about that, but hopefully that clears it up. I doubt it. But yeah, I think anyone trying to learn Python for the first time from this, I'm not sure. I guess I would recommend learn Python the hard way and automate the boring stuff. Those are tried and true, tested beginner resources. this video is not meant to be like that. I apologize. All right, so let's see here. With open. Okay, so now corrected. So let's do a new. Let's do corrected.txt for writing as target file. Line in reader. Target file dot write line. If you do not or cannot use line endings as a means of breaking up your data, as in the case of a large binary file, you can read your data in chunks. You pass the number of bytes read in each chunk to the file object's read method. When there is nothing left to read, the expression returns an empty string. Okay, so let's say that it wasn't a text file, it was like a JPEG, a PDF, something that Python can't bring in and display on your screen. You can just bring it in as binary data, and you don't have to worry about whether or not it can be processed, because you're just processing it as ones and zeros. So I could do that with my resume. Let me put a copy of it in here, because my resume is in it's a PDF. So let's see here. Oh, here we go, Java searching folder. So here's the repo I use for my resume. So let's copy the PDF. Okay, and then we'll put it in the My Projects. Okay, My Project, yep, what we're using for this. So we're gonna paste this in here. There we go, and now, obviously, if I were to try to bring that in, so let's try with open resume. I don't think it's called that. I forget what it's called. Okay, yeah, it's called this. Oops. Okay. I thought it was called like resume.pdf, but I have my name and then the year I last updated it. I need to update it again. And the yeah, and then resume. So let's see here. Let's just try a read without the binary. And we got to use the proper syntax for the with statement. We'll do data equals f.read. And we can see char map, we can't decode it. It's a PDF. It has no idea what you're talking about. But if I were to do this, -rb, read as binary, now I've got, I don't have that error message. And you can see I've got bytes. But if I print it out, I've just got, you know, ones and zeros represented in hexadecimal. So it doesn't really do much for you unless you're able to, unless you want to do something with the bytes. Okay, so let's just type out exactly what they've got there. Yeah, so I don't know where they get this process data function from, but I do not have it. So this isn't going to work for me. So yeah, I'm not sure where this process data function is coming from, but let's see here. Let me read this one more time. If you do not or cannot use line endings as a means of breaking up your data, as in the case of a large binary file, you can read your data in chunks. You pass the number of bytes read in each chunk to the file object's read method. When there is nothing left to read, the expression returns an empty string. Okay, so yeah, so here we're, oh, I see. So this is just, so we can do a print statement. Okay, so this is just meant to be a like pseudocode. It's just saying whatever you want to do to that data, you can do it to just a chunk of that data at a time instead of all the data at once if you use this while statement under this with statement here. So you can read in a certain amount of your data and then process that amount before processing the rest. And that'll prevent you from overtaxing your system by reading in too much data at a time. But you can only do that if you read it in as binary data. Okay, I totally get it. All right, so let's move on. I don't know if okay, I've got my bookmark here. Next section is decrypting text. There are many times you need to encrypt text to ensure, oh, it's actually encrypting text. There are many times you need to encrypt text to ensure security. In addition to Python's built-in package hashlib, there is a widely used third-party package called Cryptography. Let's take a look at both. So the first one we're going to look at is hashing with hashlib. To be secure, user passwords must be stored encrypted. A common way to handle this is to use a one-way function to encrypt the password into a bit string, which is very hard to reverse engineer. Functions that do this are called hash functions. In addition to obscuring passwords, hash functions ensure that documents sent over the web are unchanged during transmission. You run the hash function on the document and send the result along with the document. The recipient can then confirm that the value is the same when they hash the document. The hashlib includes secure algorithms for doing this, including SHA-1, SHA-224, SHA-384, SHA-512, and RSA's MD5. This is how you would hash a password using the MD5 algorithm. Okay, so this one we will type out all the way. The last one, without having a function defined that isn't pseudocode and that is something that, I mean, I guess I could do print. Let me try that. Okay, so now we printed the whole thing out, but we printed it in chunks instead of all at once. Okay, moving on to the next one. Okay, so I think hashlib is part of the standard library, possibly. Okay, let's use an actual password. Let's get secure here, and let's use password as the password. And then b secret equals secret code. So secret is what we defined here, and then dot encode is something that will convert it to. Well, let's see what dot encode does. So we'll hit enter, and we'll do a type on b secret. Gotta spell it right though. So yeah, that's what I thought it did. It encodes it to bytes. Okay, so now that it's bytes, we can hash the bytes. Okay, and here's our MD5 digest. This is in bytes though, so I think there's going to be another step to convert it. Oh, I don't see it. Notice that if your password or document is a string, you need to turn it into a binary string by using the encode method. You have to do that before you hash it. I didn't know that. But I think you can unhash it by doing the decode method. So we can decode it to UTF-8. Can't decode by invalid continuation by. What if we just leave this blank? Okay, it still doesn't work. Okay, so. Okay. Well, I wish they would tell you how to get the actual hash. Anyway, that's with hashlib. Hashlib, I think you'd want to use cryptography. So that's what the next section is about, encryption with cryptography. The cryptography library is a popular choice for handling encryption problems in Python. It is a third-party package, so you must install it with pip. Symmetric Key Encryption is a group of encryption algorithms based on shared keys. These algorithms include Advanced Encryption Algorithm, AES, Blowfish Data Encryption Algorithm, DES, Serpent, and Twofish. A shared key is similar to a password that is used to both encrypt and decrypt text. The fact that both the creator and the reader of an encrypted file need to share the key is a drawback when compared to asymmetric key encryption, which we will touch on later. However, symmetric key encryption is faster and more straightforward, and so is appropriate for encrypting large files. So asymmetric is more secure, but symmetric is faster and more straightforward. So larger files, you might want that sort of method. Oh, something beeped. Okay. All right, moving on. FIRNet is an implementation of the popular AES algorithm. You first need to generate a key. All right, so first thing I'm going to do is just see if I can import cryptography. And I cannot. So we got to do a pip install. Okay, and I had my virtual environment open here. So that's the other great thing about virtual environment. I'm installing all of these modules. I might not want taking up space on my computer forever. So when I'm done with this, I just deactivate the virtual environment, delete this folder, and now all that space that these were taking up is freed up again. I don't have things just laying around unused if I'm not using the project. Okay, so we're gonna do from, yeah, and look at this, I can, with Python, I can even choose the, yeah, I can tab things out, I can down arrow, really nice. There we go. You need to store this key securely as you need to decrypt. Keep in mind that anyone who has access to it is also able to decrypt your files. If you choose to save the key to a file, use the binary data type. The next step is to encrypt the data using the FIRNet object. Okay, so F equals FIRNet, and we're going to use the key we generated before, and then we're going to use this key to encrypt our message. And it's going to be a binary message, but you can just write it not in binary. So I'm going to write secret message. There you go. And so let's encrypt the message. Encrypted. So first of all, let's take a look at the type of this message. It's bytes, because we have that B there. Now let's see what happens if I encrypt the message. Still got bytes. Let's see what we got though. Okay, so now we've got a hash instead of the secret message. If we the unencrypted, we can just see the message there, plain and ready to read. You can decrypt the data using a fernet object created with the same key. Okay, and there's the original message. Asymmetric key encryption uses a pair of keys, one public and one private. The public key is designed to be widely shared, while a single user holds the private one. The only way you can decrypt messages that have been encrypted using your public key is by using your private key. This style of encryption is widely used to pass information confidentially both on local networks and across the internet. One very popular asymmetric key algorithm is the Rivest-Shamir-Adleman RSA, which is widely used for communication across networks. The cryptography library offers the ability to create public/private key pairs. Okay, and I can't actually type that fast. Looks like they're allowing me to tab out just about everything. This is really nice. I love this. Okay, so we've got a private key now. Let's take a look at that. All right, and let's make a public key. Oh, I don't know why this line is there twice. It looks like it's there with it invoked and with it not invoked. Okay, so now we've got it as a method. Let's run it again with it invoked and see what we've got now. Okay, so now we've got the actual key. So let's print that out. There we go, and we got the same thing they got. A cryptography object. Yeah, a public key, an RSA public key object from the cryptography library. You can then use the public key to encrypt. Okay, so let's do that. Message equals another secret message from hazmat asymmetric import padding from is it the wrong one? There we go. Excellent. Okay, you can use the private key to decrypt messages. Okay, there we go. So we decrypted it. The OS module. The OS module is one of the most used modules in Python. This module handles many low-level operating system calls and attempts to offer a consistent interface across multiple operating systems, which is important if you think your application might run on both Windows and Unix-based systems. It does offer some operating-specific features, os.o_text for Windows and os.ocloexec on Linux that are not available across platforms. Use these only if you are confident that your application does not need to be portable across operating systems. Example 2-1 shows some of the most useful additional methods of the OS module. So we're going to go through all of these. We got to import the module first. You can see if I did this. It would give me a name error because OS is not defined. That's because I didn't import the OS module. Okay, there we go. So we printed out. Yeah, so you can see we were able to use this list dir command instead of passing it the dir command. That's great because on Linux you'd have to use the ls command to do the same thing as the dir command on Windows. So instead of using that specific command and having it fail if you're on the wrong OS, you can just use this .list dir and you don't have to be concerned with what kind of operating system you're on, which I desperately need to do as soon as I can in some code I've written, because that might be a thing. Okay, so sweet. Yeah, this is really good. So let's do rename CRUD handler. I'm not sure what a CRUD handler is. I think it's control. I think it's like create, read, update, delete, or copy, read, update, delete, I think. I don't know. Oh, that didn't work. Oh, okay. We don't have that file. Okay, but you can see same thing as here. To rename a file would be a command specific to your operating system. But if you have Python and you use this os.rename, it doesn't matter what that command is. You don't even have to know it. As long as you've got a Python shell, you can rename a file, you can change the permissions on the file, you can make a new directory, you can make multiple new directories, you can list out the directory just using these same methods without having to know what your OS supports. As long as you get Python up and running on it, you don't have to worry about the specifics of your operating system if you're using this. All right, so get stats about directories. These stats include the, oh, you know what? I'm gonna do a note on this because coming back to this will be like really useful. Like this will be a good reference for me. Okay. So we're gonna go here and we're gonna do a highlight on this. So you can see if I open up my notes here, we can see the most useful additional commands. So I can just open it and be like, okay, well that's good. Okay, so that's a tidbit from this book I want to save and come back on the most useful additional methods of the OS module. And I could even just say most useful additional methods of the OS. Yeah, I can even just take this as a note. Let me do that. I'm gonna, because then it's more apparent. Okay, so here's my highlight. Most useful additional methods of the OS module. Take here, here it is. Okay, so moving on to managing files and directories using os.path. In Python, you can use strings, binary or otherwise, to represent paths. The os.path module offers a plethora of path-related methods for creating and manipulating paths as strings. As previously mentioned, the OS module tries to offer cross-platform behaviors, and the os.path submodule is no exception. This module interprets paths based on the current operating system, using forward slashes to separate directories in Unix-like systems and backward slashes in Windows. Your program can construct paths on the fly that work on the current system, whichever it is. The ability to easily split and join paths is probably the most used functionality of os.path. The three methods used to split paths are split, basename, and dirname. All right, so let's try this. Okay, so this is going to be, what's CWD? Let's try it. So we already had it imported, but we'll do it again. Okay, so that works. Okay, so this gets your current directory. So there we go. This is the directory we're in. It's kind of like the command pwd if you're on Linux, but you can figure that out without knowing the pw command. You can just use, as we were discussing before, a command specific to Python. And as long as your system's running Python, it doesn't matter what it is, you can find out your current directory. Okay, so now we've got that split up. All right, let's see what the next part is. Okay, so we got the current working directory. We split the leaf level of the path from the parent directory. We returned the parent path, and then we returned the leaf path. You can easily use os.path.dirname to walk up a directory tree. There we go. So we printed out every folder above the folder we're currently in, which is the My Project folder. Using files to configure an application at runtime is a common practice. Files in Unix-like systems are named by convention as .files ending with rc. Vim's .vimrc file and the bash shell's .bashrc are two common examples. You can store these files in different locations. Often, programs will define a hierarchy of locations to check. For example, your tool might look first for an environment variable that defines the RC file to use, and in its absence, check the working directory and then the user's home directory. In example 2-2, we try to locate an RC file in these locations. We use the file variable that Python automatically sets when Python code runs from a file. This variable is populated with a path relative to the current working directory, not an absolute or full path. Python does not automatically expand paths, as is common in Unix-like systems, so we must expand this path before we use it to construct the path to check our RC file. Similarly, Python does not automatically expand environment variables in paths, so we must expand these explicitly. All right, so let's do this example. I might need to take a quick break here, but I think I can go significantly longer if I do the Okay, so I'm not going to, oh, I see, okay. We're just defining a function here. Okay, so there's just a lot here. I think I'm gonna skip this example, and my directory is obviously not the same as theirs, so I probably won't even get results anyway. But let's read in plain English what they did. So they checked whether the environment variable exists in the current environment. They used join to construct a path with the environment variable name. This will look something like that. they expanded the environment variable to insert its value into the path. They checked to see if the file exists. They constructed a path using the current working directory. They used the expand user function to get the path to the user's home directory. In addition, they expanded the relative path stored in file to an absolute path. And finally, they used dir name to get the path to the directory holding the current file. The path submodule also offers ways to interrogate stats about a path. You can determine if a path is a file, a directory, a link, or a mount. You can get stats such as its size or time of last access or modification. In example 2-3, we use path to walk down a directory tree and report on the size and last access time of all files therein. So I think for big files like this, there is a Git repo. So if I go to table of contents, yeah, and I go to using code examples, there should be a Git repo. Okay, so yep, here's the Git repo. So oh, here we go. So here's the code example. This is going to be, let's go back to the bookmark we had. Import fire. I don't know if I have that. Yeah, I don't have a module named fire. Okay, but this is example 2-3. So chapter 2. I don't see. So it's not going to be under notes. Is it going to be under doc source? Chapter 2? No, I don't see any. So unfortunately, yeah, I thought they would have it, but they just have. Yeah, so this is not. They don't have the. Yeah, they don't have the code just available. Okay, some books do. This book does not. I thought it did. Oh well. So let's kind of gloss over this. This is a OS path walk, and then we get back information about it. So let's read what we did here. So we did, number 1 here. So os.list dir returns the contents of a directory, construct the full path. Then they constructed the full path of an item in the parent directory. Then they checked to see if the path represents a file. They got the last time the file was accessed. They got the size of the file. They checked if the path represents a directory. And then finally they checked the tree from this directory down. You could use a script like this to identify large files or files that have not been accessed, and then report, move, or delete them. All right, I'm going to take a break here, but I'll be able to come back and keep going. All right, I am back. Hopefully this is near the end of chapter 2. That would be nice. Hopefully that's not a pipe dream. No, there's still a lot to go in chapter 2. Okay, well, I didn't know there was so much left. If there's that much left, I guess I'd rather just. Yeah, I guess I'd like to put more into a. I don't need that. Here, let's go here. Okay, so this is walking directory trees using os.walk. So I can get through that. I can get through Oh, chapter 3 is right here. Yeah, we're almost done with chapter 2. So let's finish up chapter 2, and then the next video will be the beginning of chapter 3. So this is walking directory trees using os.walk. The os module offers a convenience function for walking directory trees called os.walk. This function returns a generator that in turn returns a tuple for each iteration. The tuple consists of the current path, a list of directories, and a list of files. In example 2-4, and now there's a link here, so maybe that'll take me to the... Oh, that took me back to example 2-4 here. So that's a link back to something I was at before. Yeah, because the one listed here is example. Oh, it is example 2.4. Okay. So it didn't take me back. It just took me to the same page I was on, but it kind of confused me. We rewrite our walk_path function from example 2-3 to use os.walk. As you can see in this example with os.walk, you don't need to test which paths are files or recall the function with every subdirectory. All right, this one I will type out just because we're so close to the end and I've got some steam left. Okay, and I'm not sure if they want this last access to be inside of the for loop or outside. Oh, no, they want it to be inside because they're using the file path name. So they want to use it for each index in the for loop. Okay, and similarly for this size here, they want that to be in the for loop as well because they're using file path. Okay, and then yeah, the indentation. Yeah, see, this is what I mean, like, I mean, of course, on a paper book, like, I wouldn't be able to take a note or anything like that. But you know, you can make a note on paper books pretty easily, and then like I could see all the formatting, all that would persist and stuff. Like, I've really been slow to adopt digital books because I just see them as more limited than paper books. Like, there's not a, especially with like copyright stuff, like free tutorials are formatted better too. There's, like, I see it kind of as like a waste of money to like buy a digital book because you can probably just find a free tutorial and you don't have to deal with this garbage here. All right, but moving on, paths. But this book has been good so far. One thing you get from a book, which can be nice, is I guess more than just a tutorial, because a tutorial I find like you generally do a tutorial because you already know like what you need to do or learn, and I think a book can kind of teach you that. You can just say, hey, I want to learn about DevOps, you know, how do I do that? The book will tell you, and then after you've read the book, you can go do all the tutorials, dive into it deeper. But if you never bought that book, you wouldn't even know what tutorials to do. I guess you could just Google for it. You could just do like learn DevOps. And I mean, then you get like these sorts of classes, but you can say like top free tutorials to learn DevOps. There we go, and here we go. We've got a Udemy course that's free. We've got yeah, so this is probably a better way to do it, but this would be a part of my wild networking series if I were to do something like this. I am doing something like this right now. I'm doing it with the RFC, but this is, anyone who's watching this, I would probably recommend doing something like this. Yeah, because look at this, you can just enroll in a free course. All right, but let's keep going on this book. So far, I have been enjoying this book. Paths as objects with pathlib. The pathlib library represents paths as objects rather than strings. In example 2-5, we rewrite example 2-2 using pathlib rather than os.path. Okay, and that's a long time. So we'll just read the summary of what they did again instead of typing everything out. So here we go, number 1. As of this writing, pathlib does not expand environment variables. Instead, you grab the value of the variable from os.environ. Number 2, this creates a pathlib.path object appropriate for the currently running operating system. You can construct new pathlib.path objects by following a parent path with forward slashes and strings. The pathlib.path object itself has an exists method, call as _ postix to return the path as a string. Depending on your use case, you can return the pathlib.path object itself. The class method pathlib.path.cwd returns a pathlib.path object for the current working directory. This object is used immediately here to create the config_path by joining it with the string rc_name. The class method pathlib.path.home returns a pathlib.path object for the current user's home directory. Create a pathlib.path object using the relative path stored in file, and then call its resolve method to get the absolute path. This returns the parent pathlib path object directly from the object itself. Okay, so the next section we'll be going over is working with the command line. So the first thing I'm going to do, so I've got a stale bookmark here. I'll remove that. So yeah, and so I'm kind of inspired by the Google search I did to learn DevOps for free. Let's see what we got for learning Python code architecture for free. Because I was thinking about buying another book next for that, and I might want to see. I think like I wonder if the difference between buying a Kindle book like I've got here and having like a free course like is like the, so yeah, introductory to intermediate. Like I wonder if there are any advanced courses that are free. Like I wonder if that's where the line is. Ah, here we go. Here's a good one. Dive into Python 3. Oh, okay. This doesn't matter. It's just the differences between 2 and 3. For some reason, there's a book written about the Python 3 tutorial course. Okay, here we go. Here's some advanced topics. Finite state machines. Musical scores. Oh, I didn't know you could do that with Python. That's awesome. Cool. That's really cool. I didn't know you could do that. All right, so this is a great learning resource. I'm just trying to make the point that a lot of what you want to know, you can learn for free. And I'm trying to, let's see, go directly into a Python from the ground up. Oh, that's intermediate. See, I need advanced. And I need like, yeah, I think that's, yeah, like I need an advanced Python course. And I need a course on like how to design your Python programs. So like, this is where I think it makes sense to pay for a resource, because we can see we've got a, architecture patterns with Python. Like this is exactly what I think I need. So like, I could just buy it for $40 instead of just spending hours and hours going into a rabbit hole on the internet trying to find it for free. Yeah, so might as well just buy the book. Oh, it looks like it actually just might be free here. Oh no, this is a different book. This is Cosmic Python. Oh, this looks really good. But this is for, see, I don't know if this is what I need either. Yeah, this is Cosmic Python. I'm not sure what that is. This might be what I need. Yeah, this is what I need, and this is free. Oh, this is the book. This is, yeah, this was probably like the old version of the book. So I think I'm gonna save this somewhere. I'm not sure where. I don't know. Yeah, most interesting. Okay. Yeah, and then I might just do. Oh yeah, okay. So you can read this book here for free on this site. But even so, like, it is kind of nice to have, all my books in my library here, and then notes. It's easier to refer to it. It's in an all-in-one spot. Like, yeah, I can go and I can access this anywhere, but I can't access my notes, I can't access my bookmarks. So is that worth $40? I don't know, but I do have the book here I can go through without buying it. Okay, so but that's the end of chapter 2 of this book here, Python for DevOps. So I will see you in chapter 3.